Welcome to an alternate format for integration by parts. So recall the rule for integration by parts says that the integral of u dv is equal to u times v minus the integral of v du. So we can express this visually in a table. The way that I write this is I do u and then dv as my start. So I usually label these columns as u and dv just to keep track. So whatever our u is, we'll put in our first component. Whatever dv is, we'll put in our second column. Then we will go ahead and differentiate that first column. So we'll take the derivative. And in our second spot, we will put du. And on the right-hand side, we will go ahead and integrate. So on the right-hand side, we essentially wind up with v. When we integrate dv, we get v. Now, our formula says that we should multiply u and v. So on the diagonal, we're just going to multiply u times v. And then it says that we subtract the integral of that bottom row, v times du. So we're going to take the positive product of that first diagonal, u times v, and then subtract the bottom integral of the bottom row, v times du. So this is how I usually write integration by parts when I am performing it myself. So for example, let's go ahead and evaluate the indefinite integral, the integral of x times cosine of 3x dx. So in this case, we have our u and our dv. I personally would pick x as my u. And I would pick cosine of 3x as my dv. You can write it, sorry, that's supposed to be an x under the u. You can write the dx if you want to show the dv. I usually get lazy and stop writing those dx's. Then we'll go ahead and differentiate on the left-hand side. We will integrate on the right-hand side. So if we differentiate x, we just get 1. If you want to write that as du, you can, or we can leave it alone. Integrating on the right-hand side, integral of cosine of 3x goes to 1/3 sine of 3x. Then we take the product of that first forwards diagonal, that x times 1/3 sine of 3x, and we subtract the integral of that bottom row. So this becomes, we have the integral of x cosine of 3x dx is equal to x times 1/3 sine of 3x minus the integral of 1 times 1/3 sine of 3x dx. So this becomes our integral is 1/3 of x sine of 3x. Integral of sine is negative cosine. So we will have minus, if we want to run some u substitution. Oh, I should have mentioned going from cosine 3x to 1/3 sine of 3x, I was technically running u substitution. Technically, I was setting u equal to 3x. So if we go over running our u substitution, if we set, let's do s equal to 3x, then we have ds is 3 dx, or 1/3 ds is dx. So we would have been looking at the integral of cosine of s times 1/3 ds. That gives us 1/3 sine of s, and hence our 1/3 sine of 3x. Similarly here, if we do our substitution, if again we set s equal to 3x, we have ds is 3 dx. Going through again, we wind up getting that we would have minus a negative 1/9 cosine of 3x. And then of course we have our plus c. Let me update my screen quickly, I apologize. So again, that integral of 1/3 sine of 3x. Sine of 3x will go to negative 1/3 cosine of 3x. So that goes to a total of negative 1/9 cosine 3x. And that whole thing is being subtracted off. Then we have our plus c. So we wind up with 1/3 x sine of 3x plus 1/9 cosine of 3x plus c. So again, this is our integral of x cosine 3x dx using our alternate format for writing out that integration by parts. It's completely up to you which format is more straightforward. I like to use this one because it lends itself towards something called rapid repeated integration by parts, which we will learn next week, that can be used when we have to perform multiple series of integration by parts to finish the integral.